table of contents looks fairly standard. If you look more deeply into the individual sections of the book, though, you will see differences in how the course is taught and how the book is written. One of my favorite sections is the opening section on limits, which is arguably the most critical section in the whole book. In that section, in a very concise and visual way, we've presented limits through two seemingly different applications of limits. One is slopes of tangent lines, and one is instantaneous velocity. And using just very brief arguments and very effective figures, we've shown how those two mathematical problems relate to this fundamental idea of limits. It's a wonderful introduction to the chapter on limits, and indeed it sets the scene for most of the book. Another part of the book in which you'll see some differences comes in the second semester. Anyone who's taught Calculus 2 knows that the course often starts to unravel when sequences and series need to be covered in the remaining few weeks of the semester. We gave a lot of thought to this problem and tried to think of a way to overcome the difficulties of teaching this material. The first task is to tell students the difference between a sequence and a series. The chapter opens up by talking about sequences, distinguishing them from series, and then the chapter is fairly standard in that sequences are discussed and all of the convergence tests for series are discussed. Then we take a break, new chapter begins, and now we talk about power series. So power series are distinguished from sequences and series in a separate chapter, and we believe that's going to make teaching of this material a whole lot easier. One of the reasons I decided to attempt to write a calculus book was because of Calculus 3. At the time I was teaching Calculus 3, and I was struck by how the book that I was using seemed to cover the material in a very nonlinear way. And I was convinced that there had to be a better way through this material. The story of Calculus 3 is actually very simple. Students have to be taken from problems in 2 dimensions, which they've been doing for 2 whole semesters, and now they have to move into 3 dimensions. Now that happens in 2 ways, and those 2 ways should be very clear to students. First, we can talk about increasing the number of independent variables and leaving one dependent variable, and that leads to functions of several variables. On the other hand, a completely different path is to leave the number of independent variables alone, that is 1, and increase the number of dependent variables, and that leads to vector-valued functions. Those 2 paths should be made absolutely clear in a book. As you all know, calculus comes to a very elegant end when the 2 themes of Calculus 3, functions of several variables and vector-valued functions, come together, and of course the culmination is vector fields, which is the subject of the last chapter of our book. I'm Bill Briggs from the University of Colorado. I thank you for your interest in the book and hope you give it serious consideration.